Yeah. So, hi guys. Welcome to Geography series, Lesson 6. In previous class, we have talked about interior of the Earth, earthquakes, and P and S waves and seismicity. Okay, seismicity is nothing but earthquakes. We have talked about them, and we have dealt in very detail about interior of the Earth. Okay. Uh, yeah, and uh, I have told you that I will give the diagram of interior of the Earth in in previous class. I have told you that I will give you it in next class, and yeah, I will give you the diagram at the end of the session. Okay, so first we will look into what is a volcano and landforms associated with it. Okay, yeah, fine. Volcano. Volcano is nothing but a place. It is a place actually. Volcano is nothing but a place where the hot magma and gases inside the earth uh, comes to the surface and comes to the ground and spreads. It is called as volcano. That place is called volcano. So volcano is a place where uh, the hot magma and the gases inside the earth comes into contact with the ground and spreads on the ground. It is called as a volcano. Okay. So, what actually comes from inside of the earth? We have all learned about asthenosphere, right? Asthenosphere, we have magma. So that magma, makes its way through the crust of the earth and comes out as lava. So the material that is coming out when it is inside of the earth, we call it as magma. Once it makes contact with the ground, we call it as a lava. Okay, and how this comes to outside of the earth means it makes a pipeline. We call it as a conduit. I will write it down. Okay, it is called a conduit. It is a pipe-like structure. Through that conduit, the magma makes its way to the ground. Okay, and once it comes into contact with the ground, we call magma as lava. Okay, yeah. And what other matters comes with the lava. Along with the lava, we can see pyroclastic debris. Debris is nothing but waste material. Waste material is called as a debris. Okay, yeah. It is one thing, and secondly, ash is formed. Okay, we can see during an eruption, we can see lava is coming out, pyroclastic debris is coming out, ashes are coming out, and gases are coming out, and these gases majorly contain nitrogen and sulfur compounds. Okay, yeah. So the materials that spreads out, the material that spreads out, you know are lava, pyroclastic debris, ashes, and gas. Gas mainly contains nitrogen and sulfur. This is one thing. Yeah. So yeah, we have talked about thing called lava. What's the lava? The magma inside the molten metal is called as magma. Once it comes into contact with the ground, we call it as contact with the ground. We call it as lava. Okay. This lava is of two types actually. Okay. See, this is type one. So here we can see earth crust. It is ground. This is ground. Okay. This is earth's crust. Okay. This is crust and this is asthenosphere. From asthenosphere, the magma rises up, develops cracks in the earth's crust, and makes its way through a pipe called as conduit. Okay, it is conduit. The magma rises, hits the earth's crust, makes its way to the ground through a pipe-like structure called as conduit. Okay, so I said types of lava, right? The first type of lava is which is basic in nature. Okay, we have acids and bases, right? So one type of lava is basic in nature. The acidity and base nature of lava depends upon the materials present inside it. Okay, so based on the materials present within the lava, we have basic lava and acidic lava. First type is basic lava. Okay, this basic lava is highly fluid. First thing is basic. We can also call it as basalt. Okay, it is highly fluid in nature. First, it is highly fluid in nature. Okay, and see, we said that it is highly fluid in nature. It's it makes its way through conduit, and spreads very far to far distances. Okay, as it is very fluid in nature, it travels very far distances. Once it comes like this, it travels very far distances. Okay, sometimes like hundreds of kilometers, they travel hundreds of kilometers like this, and on the ground, and gets solidified like this, in a straight way or a slightly concave way, they get solidified. Okay, further, another layer is formed above it. It gets solidified, and it gradually solidifies and forms into this shield shape. It is shield, warriors hold shields, right? uh, as it is very fluid in nature, it travels for a longer distances. Okay, and due to gradual solidification and traveling of the long distances, this lava gets solidified and forms into shield shaped structure. Okay, shield shaped structure or dome shaped structure like this. If this is the ground, if this is the ground, the lava will be like this. I mean, yeah, the volcano will be like this. It is somewhat flattened in nature. Okay, like this, this is the shape, this will be the shape. And if this is the ground, it will be like this. Okay, this dome shape is called as a shield volcano. It is formed due to basalt, basic lava. Okay, second type, acidic. It is viscous in nature. Viscous in nature means it has high friction. It cannot travel longer distance. Less fluid in nature. Okay, if something is less fluid in nature, we call it as viscous. If any liquid or a fluid has high viscosity, it will have a tendency to stick. Okay, so that it cannot travel for far distances. So yeah, this is Earth's crust. The magma is making its way through this conduit. Okay, and comes out on the ground. As it cannot travel for longer distances, it gets solidified in a cone shape. Okay, not dome, cone shape. Due to gradual solidification, a cone shaped volcano will be formed like this. If this is the ground, this is how we can see. Okay, a cone shaped, right? So we have learned about two types of lava, basic and acidic. The basic lava tends to form, a dome-shaped volcano, and acidic lava tends to form a cone-shaped volcano. Okay, and dome-shaped basic lava is highly fluid in nature, so that it travels for longer distances, and acidic lavas are viscous in nature, so that they cannot travel for longer distances and get solidified in form of a cone. Okay, once it comes out like this, basic lavas travel for longer distances, and this acidic lavas get solidified like this. It comes out and solidifies like this, comes out, solidified like gradually, and forms into a volcano. I mean, cone shaped volcano. So we have learned about types of lava. A new word called conduit. A conduit is nothing but a pipe-like structure which facilitates the flow of magma from interior of the earth to ground. Next, the lava, once it reaches the ground, it It flows like a fountain, okay, through and forms a vent here. Vent is nothing but an opening, okay. That vent is called as a crater. Crater is always like, in concave shape like this, a crater. If you see, if you take a volcano like this, it will have a opening like this, okay. This part, this vent or opening is called as crater, okay. So what are the things associated with the volcano? Magma, pyroclastic debris, ashes, gas, conduit, crater, okay. These are the things associated with a volcano. Volcano is a place where the hot magma inside of the earth comes into contact with the ground, okay. And due to, different types of lava, different types of structures are formed. A dome shaped structure and a cone shaped structure, okay. And there is another concept called as hotspot volcanoes. See, generally in previous classes we have learned that these volcanoes are formed during the either convergence or divergence. So, okay, what did we studied during a convergence? When one plate moves towards each other, the magma hits the crustal part and comes out as volcano. And during divergence, we have seen the formation of mid-oceanic ridges. They are also volcanic in nature. But scientists cannot explain, not able to explain why volcanoes are formed in middle of the plate. If we take Pacific plate and Philippines plate, you remember, right? Pacific plate and Philippines plate, they both converge, okay. While they are converging, we can see many trenches and volcanoes are formed at the fringe. Fringe means boundary. That is Japan, Philippines, Java, Sumatra. Okay, but Hawaiian Islands are present on Pacific plate, right? But they are present on middle of the Pacific plate. They are not present at the ends of the plate. If something is present at the ends of the plate, yeah, it's okay. We can explain why volcanoes are formed. Similarly, uh, convergence of Nazca plate and South American plate also results in the formation of volcanoes and trenches. But Hawaiian Islands are volcanic in nature. Yeah, we have learned that these volcanoes, once they come onto the surface of the earth, we call them as islands. So Hawaiian Islands are nothing but they're volcanoes only. Okay, but they're present in the middle of the plate. So to explain this, the further discoveries led to a concept called as mantle plumes. Plumes. Mantle plumes. What is a mantle plume? Whenever a plate moves, there will be a certain place inside the mantle, okay, or inside of the earth called as mantle pool. This mantle pool is fixed. Mantle plume does not move. If it is mantle plume, the plate moves like this, okay. In different parts of time, different parts of the plate comes into contact. Let's say 70 million years ago, this part of a plate comes into contact with this mantle plume, okay. 60 million years ago, this part of the plate came into contact, and 50 million years ago, this part of the plate comes into contact with the mantle plume. These mantle plumes are certain places inside the earth which are fixed and always tries to, oozes out the magma. They always these mantle plumes. What happens inside a mantle plume means the magma rises, okay, in a violent way, in a violent or explosive way in this mantle plumes. So whenever certain parts of a plate comes into contact with these mantle plumes, volcanoes are formed in middle of the. So through this concept, scientists are able to explain formation of volcanoes in middle of a plate. Best example is Hawaiian Islands, okay. See, this is a mantle plume, sorry. This is a mantle plume. See, At certain point of time, this part of the plate came into contact with the mantle plume. Lava magma came out and formed a a volcano here. Okay, the plate is moving like this towards this way, and after a certain period of time, see, this plate is moving like this. This the volcano is now, after certain point of time, this volcano is behind the mantle plume. Mantle plume is here only. The plate is moving. Okay, uh, this mantle plume is behind, and a new volcano is formed here. Okay, and after certain point of time, these two volcanoes were behind this mantle plume, and then active another volcano is formed here. Okay, so this series of extinct, dormant, and active volcanoes are called as hotspot volcanoes. Okay, hotspot volcanoes are nothing but they're places where we can see a series of extinct, dormant, and active volcano. Extinct, it formed millions of years back. There is no mantle plume to you know uh, make the magma come out. So after certain point of time, in the second diagram, this active volcano became a dormant volcano. So it's not extinct; it's dormant. Sometimes it erupts. It's inactive in nature, but at certain points of time, it will become uh, you know uh, inactive. At certain points of time, it will become active, and there will be another volcano on top of this mantle plume, and it is active volcano because there is continuous supply of magma from this mantle plume, so that eruption happens, so it is active in nature. After certain point of time, what happens, this active volcano becomes a dormant volcano, and at this mantle plume place, another active volcano will be formed. Okay, so this series of extinct, dormant, and active volcanoes are called as hotspot volcanoes. Best example is Hawaii Islands. Yeah. Next, landforms associated with volcano. They are extrusive and intrusive. Okay. Extrusive means the formed on the ground. Intrusive means they are formed inside of the earth. Yeah. First one would be shield volcano. See, as we learned earlier, she the shield volcanoes are larger. One of the largest volcanoes in the world are shield volcanoes. Why shield? We have learned just previously that basalt or basic lava is very fluid in nature, and once it comes in contact to the ground, it forms for larger distances and forms a dome shaped volcano. This is either dome shaped or a shield shaped. It is called as a shield volcano. See, if you observe here, see, the lava is flowing for very long distances, and there will be another way like this, and gradually this longest path gets solidified and forms into this a shield shaped volcano. It is almost flattened in nature. Okay, it is called as shield volcano. It is one of the largest volcano, one of the not one of the it is the largest volcanoes in the world. There is a shield volcano in Hawaiian Islands. I think its name is Mount. Uh, it starts with M. Sorry, I'm not able to recollect it. It's the base of the shield. That shield volcano is 160 kilometers wide. Okay, so imagine how long that basalt flows. That basalt flows and solidifies into a shield shaped structure called a shield volcano. On top of a shield volcano, we have vent called as a crater. Through that, only the lava flows out. That is one thing. Second thing, shield volcanoes are associated with low explosivity. Okay, why low explosivity? Because the lava that gets into shield volcanoes is basic in nature, and it is fluid, highly fluid. No, so it travels very slowly and gets settled on the ground as a dome-shaped structure or shield-shaped structure. So it is associated with uh, low explosivity. Okay, yeah. Sometimes what happens, this lava travels up to the vent, right? And while traveling, see, that's crust, and we, yeah, shield shaped volcano travels, and sometimes the lava here gets solidified. Okay, the lava here gets solidified here, right? But there will be a continuous heating of magma from the inside of the earth. This is crust. Due to this continuous hitting, at some point of time, as lava on the surface is solidified, due to continuous hitting of the lava from interior of the earth, there will be sudden explosiveness. Okay, there will sudden explosiveness, and uh, the top part of the shield volcano develops into a cinder called as cinder cone. Cinder means nothing but something which is burnt or ruined is called as a cinder. So the top of a shield volcano, that is the crater, gets ruined due to strong hitting of the magma, and there is a resistance from the solidified part of the lava. To come out, it will hit strongly, and at certain point of time, this solidified part inside of the volcano gets broken, and lava comes out explosively. Once it comes explosively, it breaks the vent. It breaks the vent and forms this kind of structure. So it is called a cinder cone. Okay, yeah. Another thing is, shield volcanoes have very gentle slopes. See here, this is a slope. See, they are very gentle because it is almost flattened to the ground. It is gentle slopes. So we have learned shield volcano, cinder cone, and third one is composite volcano. Okay, composite volcanoes are also called as stratovolcano. So composite volcanoes are also called as stratovolcano. What happens in a composite volcano? Composite volcanoes are cone-shaped volcanoes with very steep sides. See, it is very steep, almost cone-shaped volcano. This is okay. This is one thing. They are cone-shaped and have very steep sides. So the lava that flow, whenever the lava is acidic in nature, it travels for a very short distance and develops into this cone-shaped volcano. Okay, and at the vent, this is the opening, right? At the vent, what happens? This lava, as it cannot travel for longer distances, it gets settled at the top and forms layers. This white color part here, wait. You can see this white color part, right? This white color part is nothing but the lava coming out got solidified at the vent, at the opening, and uh, you know uh, it gets solidified here and formed a layer, forms layers. So this is called as composite volcanoes. These layers are called as composites. So at the vent there are layers of volcano that got solidified, and it is called as a composite volcano. Generally composite volcanoes are associated with high explosivity. Okay, yeah. Fourth one is caldera. See, I said that if this is a volcano, this is the opening. Opening is called as crater. Yeah. Sometimes what happens, the lava that's coming out will be very explosive in nature. Okay, it very explosive in nature. Okay, uh, due to that high explosiveness, see, it hits like very explosively or very aggressively, so that this part gets broken. Due to that hitting, that part gets broken, and it will be something like this. The above part got broken, and it develops into a this a depression, a wide depression. See, a wide depression. Okay, it is called as a caldera. See, it is side. It is one side, and due to continuous hitting of lava explosively, the crater part gets broken down, and it forms into this like a depression. This depression is called as a caldera. Okay, sometimes you know water gets deposited in this caldera and forms a lake also. Okay, uh, yeah, these are extrusive forms: shield, wait, yeah, shield, cinder cone, composite or stratovolcanoes, caldera, and there are another two: flood basalt and mid-oceanic ridges. We have talked about mid-oceanic ridges in a very extensive way, so I think there is no need to explain about it. What are mid-oceanic ridges and all? Flood basalt means we have talked about Deccan traps in India, right? When Indian plate is moving towards Eurasian plate, a series of volcanic events has happened, and they got solidified on the ground. They traveled for longer distances, and they are solidified and trapped on the ground as Deccan traps. For example, it's our Deccan Plateau region, Maharashtra Plateau. Okay, these are called as flood basalt. Okay, the lava is flooded. The lava flowed like a flood, and the lava is basic in nature, so it is flood basalt. Another one is mid-oceanic ridges. It is also extrusive form because it forms outside of the crust. Yeah. Now we'll learn about intrusive forms. Sometimes what happens, the magma inside the earth while traveling through the conduit or the pipe, it gets solidified in the interior of the earth only. Okay, it gets solidified in the interior of the earth only. uh, if that uh, lava comes out to the ground and gets solidified, we call it as a volcanic rock. And if that's solidified inside of the earth, we call it as plutonic rock. Okay, the magma, if it solidifies on the ground, it is called as volcanic rock. If the same magma solidifies inside of the earth, it is called as plutonic rock. Okay, so whenever uh, you know this lava solidifies inside of the earth, it develops in different shapes inside the crust of the earth. Okay, we will learn about that. The first one would be batholith. See, first one is batholith. So how these intrusive forms are formed? The lava or magma inside of the earth, while traveling towards the ground, they get solidified into certain forms called as intrusive forms. Okay, yeah. First one is batholith. Batholith is similar to a shield volcano only. Yeah, this is the crustal part, and below this we have asthenosphere. When the magma hits and comes out to the crustal part, okay, this magma gets solidified on the base of the crust itself. It gets solidified here. Okay, solidified and forms into a dome shaped structure. It is called as a batholith. Okay, batholith is nothing but a large body of magma, that gets solidified at the deeper parts of the crust. This whole part is crust. At the deeper parts of the crust, this magma solidifies, and it is called as a batholith. Okay, solidifies in form of large domes, dome shaped. Comes like this, travels like this, and solidifies into a dome at the deeper parts of the crust, and it is called as batholith. Second one is laccolith. See, laccolith. So, sometimes this magma travels, towards the upper parts of the crust. It travels in a, see, conduit, in a straight manner, and when it reaches to somewhat upper portions of the crust, it gets solidified into a dome shaped structure called as laccolith. See, this is the dome shape. The magma traveled from deeper parts of the crust to upper parts of the crust and gets solidified here into a dome shaped structure. Magma traveled like this and traveled like this, and got solidified into a dome shaped structure. It is called as laccolith. Okay. So laccolith are large massive bodies of magma inside the earth which are associated with a strong base and a conduit. They are laccoliths. And sometimes what happens, the magma travels in a straight manner and develops, see, wait, whenever, this is the crustal portion, right? Whenever the magma travels like this, it develops cracks in the crust and travels horizontally like this. It goes like this, develops cracks in the crust, and travels horizontally inside of the crust. When it travels in horizontal manner, it forms three types of structures called as lapolith, phacolith, and sills. What are they? Lapolith, phacolith, and sills. Wait, give me a minute. Okay, see, whenever magma travels in a straight way, and due to there are certain weaker parts in the crust. Due to that weaker parts, the magma can travel in a horizontal way. Whenever it travels in horizontal way and develops into a saucer shaped structure like this, it is called as lapolith. Saucer shaped structure. Whenever magma travels horizontally and develops into a saucer shaped, it is called as lapolith, saucer shape. Saucer shaped structure inside of the earth is associated with lapolith. Okay, and next, within the crustal portion, whenever a crust gets, convergence, when it gets, squeezed, uh, the materials inside the crust were folded like this. Okay, this depressed part is called as syncline, and this upper portion part is not outside, inside part is called as anticline. Okay. Whenever the plate moves towards each other, there is convergence, right? There is a pressure building upon the plate. One plate is like this, another plate is pushing it like this. Okay, and there is a pressure on one plate. When there is a pressure on a plate, the materials inside the crust, they get folded like this. Material is like this, rocky material is like this, and it folds like this, like this. Okay, like, and whenever it is folding, this depressed portion on below is called as syncline, and the top portion is called as anticline. This is one thing. So what is a phacolith? Whenever a magma travels in a straight line and gets deposited in these synclines and anticlines. It is called as phacolith. Okay, magma travels like this and gets deposited in this synclines and anticlines. The intrusive forms associated with syncline and anticline are called as phacolith. And if that horizontal forms developed in a saucer shaped structure, it is called as lapolith. Okay, and the another one is sill. See here, the magma is traveling in a straight line and traveled in a horizontal way. If and traveled in horizontal way and got solidified. If the solidified part is thicker, it is called as a sill, and if it is thinner, it is called as a sheet. Sheet. So the horizontally solidified part inside of the earth, if it is thicker, it is called as sill, and it is thin, and if it is thinner, it is called as a sheet. And another intrusive form is dike. Okay, dike means nothing but this is Earth's crust. Okay, crust. Magma coming into the crust. Whenever the magma comes into the crust, it travels in into the weaker parts of the crust like this. Okay, see, the magma comes and travels into the weaker parts of the crust like this. And during this traveling, the magma gets solidified. Okay, this solidified part is called as a dike. So whenever a magma makes its way through the fractures of the crust, or cracks of the crust, there are cracks in the crust due to continuous heating. Cracks are developed here. Whenever the lava makes its way through these cracks and gets solidified in those cracks, they are called as dikes. Okay, so we have completed extrusive form of extrusive volcanic landforms and intrusive volcanic landforms. Okay, uh, so it's, I hope it is very clear to you what's lava and what are the forms associated with it. And next concept is specific ring of fire. It is nothing but volcanoes present on the earth. Okay, see, uh, this is specific question, right? Two-third of the volcanoes, 70% of the volcanoes are present in this region only. This in this in this belt. This is continuous belt. See, world's 70% of the volcanoes are present in this continuous belt, continuous Pacific belt. This is called as Pacific Ring of Fire. Okay, 70% of the world's volcanoes are present in this present around the Pacific Ocean in a continuous belt. It is called as the Pacific Ring of Fire. So why only most of the volcanoes are formed in this belt or in this region? Because there's convergence of Philippines plate and Pacific plate. Pacific plate is very large. Even Philippines plate is also large plate. Sorry, Philippines is a minor plate and Pacific plate is a major plate. Due to convergence, what have we learned? Whenever there is a convergence, we can see deep trenches and volcanic formations. Like due to compression of the sediments, a series of fold mountains are formed. These are volcanic in nature. So due to convergence of you know uh, Pacific plate and Philippines plate, we can see deep trenches. We can see trenches in Japan, Philippines, Java, Sumatra trench. Okay, and there is a trench in California coastal region also. So due to that convergence, there are most number of the volcanoes are present in the Pacific region only, and this series of belt of volcanoes is called as Pacific Ring of Fire. What are the places that this Pacific Ring of Fire covers? It extends from first belt. It extends from Aleutian Islands. See, this rounded part is called wait. It is Aleutian Islands. Okay, from Aleutian Islands, it travels towards Japan. From Japan, it goes to Philippine, and at Philippine, it breaks into two belts. One belt goes towards Java and Sumatra. Another belt goes towards New Guinea. Here, New Guinea, and there were a series of islands in this Pacific region. They are called as they are New Guinea, Solomon Islands, Tonga Islands, and New Zealand. This is one side of the belt. Another side of the belt extends from Andes Mountains here. See, why Andes Mountains and volcanoes are formed in this in that Peru Chile coast of South America due to convergence of Naz. Due to convergence of Nazca Plate and South American Plate. Nazca Plate and South American Plate. Due to the convergence, uh, the sediments in the ocean formed into a series of folded mountains, which are volcanic in nature, and they are called as Andes. They are present along the Peru Chile coast. So this belt extends from Andes into Central America. What is the plate present in the Central American region? Caribbean plate. And the volcanic islands present here are Costa Rica, Guatemala. These are the volcanic islands present in this region, Central America. From Central America, it travels towards the western coast of America up to Alaska. This region is called as Alaska. Okay. Yeah. This is how Pacific Ring of Fire covers those places. And see here, it is Mauna Loa. Mauna Loa means previously we have talked about the largest shield volcano on Earth present in Hawaii Islands. It is Mauna Loa. See, Hawaii is present in the middle of the plate. So how a volcano can be? You see, these places, this ring of fire places, almost they are present on the ends of the plate, fringes, boundaries of the plate. So there is a proper explanation for that how these volcanoes are formed. But Mauna Loa is present in middle of the plate. So the possible explanation for this is mantle plumes. Okay, Mauna Loa. This is Hawaii. Mauna Loa volcano. Yeah, this is Pacific Ring of Fire. We talked about volcanoes and earthquakes. Mostly 70% of the earthquakes also happen in Pacific Ring of Fire only because of the subduction of due to continuous convergence and subduction of the uh, that denser oceanic plate. We can see formation of trenches and continuous earthquakes. Remaining 20 or 30% of the earthquakes will happen in here, north part of Africa and Himalayan region and northwest China. This is a continuous belt. Why? Due to divergence of African plate and Arabian plate, we can see earthquakes here. Due to this divergence only, Red Sea is formed. Due to divergence, the block gets subsided down, and we can experience earthquakes in this region, north part of Africa and Arabian region and Central Asian region, and from this Himalayan region. Okay, that extends from Afghanistan to Tibet. Why earthquakes happens in this place? Due to convergence of uh, Eurasian plate and Indian plate, and this Himalayan plate extends up to northwest China. This is northwest China. Okay, this is about volcanoes and earthquakes distribution on the earth. Another topic is hot springs and geysers. It is very small thing, nothing to worry about it. Hot springs and geysers. These are the structures associated in a volcanic region. Not wait. Hmm, Yeah. Geysers are the structures associated in volcanic region. See, if there is a volcano, yes, if there is a volcano or a place where volcanic activity is happening place, the water present inside of the ground gets contact with the those volcanic rocks, gets contact with that. See here, the water inside the earth gets contact with the volcanic rocks in the deeper parts of the earth, and the water gets heated, travels through these cracks and burst out, travels through the cracks and burst out with steam and water. It burst out. They are called as geysers. Geysers are associated with explosivity, because at the deeper parts of the earth they get so much heated and travel in a very fast manner through these cracks and burst out in an explosive way. They are called as geysers. Best example is Yellowstone National Park. We can find n number of geysers in Yellowstone National Park. Okay, and another one is hot springs. Hot springs are nothing but uh, if uh, if there is a river, the water seeps down into deeper parts of the earth, gets heated. It does not go into contact with that magma and volcanic rocks. It travels into deeper parts of the earth, and due to high temperature, it gets heated. The water from the river goes into earth. It gets heated and travels upwards. Okay, why? It gets heated in the lower parts of the earth, and it will develop a tendency to cool down and and uh, travels and comes in contact with the ground. It is called as hot springs. They have no explosivity. Hot springs can be seen in many parts of the earth. Best example in India is you know in Kasol, Himachal Pradesh. There is a place called Manikarnika. We can see many number of hot springs over there. The water is so hot, okay, in a way that there is a ritual in Manikarnika temple is there. In that temple, there is a ritual where the water is, as very high temperature, so that the raw rice, people will bring, devotees will bring that raw rice, tie it in a cloth and keep it in that water. Due to the temperature, the raw rice gets cooked into, you know uh, edible part of the rice. Okay, the raw rice gets cooked due to that heat. Why that much of heat? Because the water goes into deeper parts of the earth, seeps in deeper parts of the earth, gets heated and rises above as hot springs with very low explosivity. And as it gets heated in the deeper parts of the earth, some minerals are added to it, and hot springs are also associated with medicinal value. Okay, best example is our Kasol and Iceland also. Okay, yeah, that's all about volcanoes and volcanic landforms. And yeah, Okay, and I have also said that I will give you the diagram of inside interior of the Earth. I will give it to you now. Wait. Yeah. Okay. Oceanic crust, continental crust, upper solid mantle, asthenosphere, lower solid mantle, outer liquid core, inner solid core. Okay. Continental crust extends up to 35 kilometers. Oceanic crust extends up to 5 kilometers. Okay. From crust to up to 100 kilometers, we can see upper solid mantle. From 100 to 600 kilometers, we can see asthenosphere, nothing but our magma. From 600 to 2900 kilometers, we can see lower solid mantle. From 2900 to 5100 kilometers, we can see outer liquid core. From 5100 to 6300 kilometers, we can see inner solid core. Okay. And we also learned that crust plus upper solid mantle is called as lithosphere. Okay. Uh, from asthenosphere to lower solid mantle, it is called as mesosphere. The outer core and inner core called as barysphere. Okay. And next, uh, this crust and upper solid mantle, there is a boundary in between them. That boundary is called as Moho discontinuity. Okay. Yeah. And the boundary between lower solid and outer core is called as Lehman discontinuity. And sorry, it is not Lehman discontinuity. The boundary between lower solid mantle and outer core is called as Gutenberg discontinuity. And the boundary between outer liquid core and inner solid core is called as Lehman discontinuity. Inner solid core is made up of nickel and ferrous, so it is often called as NiFe layer also. So this is interior of the earth. Uh, please make note of this diagram. Okay, and while you are reading about uh, how P waves and S waves help the scientists to know about interior of the Earth. Make sure you keep this diagram, like while reading it, see this diagram and study, so that you will get a clearer picture. Okay, yeah. Thank you. We will meet in next class, and in next class we will talk about minerals, rocks, how plains, plateaus are formed. Okay.